Hi, welcome to part 2 of problem 6.12. So a reminder, a couple of reminders anyway. So the structure is in fact symmetrical. Because it's symmetrical, I mean exactly symmetrical. All the distance is the same on everywhere. The forces are being applied in the same direction at the same corresponding spots. We only have to figure out half the members, and that'll give us the other half automatically. In the first video, I did a bunch of pre-work showing you the various measurements that I ended up needing throughout the problem. And I had encouraged you to make sure you took a picture of that if you need to follow along. That as we went through some of the arithmetic, I would say, from a previous calculation, we know that. Okay. So the method is method of joints. That means we have to go from joint to joint to get every member. So I'm going to start at A. So I can start anywhere that I want, but I cannot calculate more than 2 unknowns at a pen. So member A. Member A has a 15 kilonewton force going up. I have, looking at the picture, member AG, and also looking at the picture coming into pin A. Well, that's not even close to going into pin A, is it? Just occurred to me I could use the arrow maker. There we go. I'll try to remember. All right, AB, AG. AB is at a diagonal. It tells me that we need to grab the X and Y components. Going to be AB cosine 5631. That's incorrect. AB sine 5631. This is AB cosine 5631. 5631 comes from a previous calculation. The angle internal to A was 33.69. So the 56.31 is the complement to that. All right. Forces in the y direction, 15 kilonewtons going up, minus AB cosine 5631 is equal to 0. Add AB cosine 56.3 to both sides. 15 kilonewtons is equal to AB cosine 56.31. Divide both sides by 56.31, and we get that AB is equal to 27.04 kilonewtons. And I have that as a positive number, which indicates that my arrow is in the correct direction. In this case, it is in compression. So 27.04 kilonewtons in compression. In the X direction, we would end up with AB sine 56.31. That'd be negative plus AG. We know that AB is 27.04 kilonewtons. Sine 56.31 plus AG equal to 0. And if you do the arithmetic, you get that AG is equal to 22.50 kilonewtons. Go ahead and fill that in, 22.50 kilonewtons, and that one is in tension, pulling away from the pin as a reaction to the member being pulled apart. So I'm going to put little check marks as we go through these so I can better tell where the next joint is. So we got AB AG, ED, and EF. All right, I'm going to pause while I get the board ready for the next pin. Thank you for your patience. I've decided to move up to pin B next. It could have been D. Can't be G because I have 3 unknowns still. So B is my next natural selection. I have a free body diagram written in B. It has 4 forces. AB, which we have already calculated. So we know that AB is 27.04 kilonewtons. There's a 10 kilonewton external force being applied in the down direction. And then the 2 other internal forces come from member BC and BG. 3 of these 4 are at diagonals. So let me go ahead and grab, or let's get it set up to grab the X and the Y directions. All right, so here's AB. $27.04. This is 56.31. Previous calculation. That makes this 27.04 sine 56.31. And this one, 27.04 cosine 56.31. BC, so I've got BC going down like this. So if BC is going down, BCX goes to the left, BCY goes down like that. This angle is 33.69 from a previous calculation. Is that true? No, it's not true. It's also 56.31. I'm gonna erase this triangle because I drew it differently on my paper and I don't want to mess the calculations up. I do it like this. All right, so this is BC sine 36 or 33.69. And this one is BC cosine 33.69 degrees. And the last one we have is BG. So BG. BG. I have BG going up like that. BG. 56.31 from a previous calculation. This is BG cosine 56.31. And this is BG sine 56.31. Well, so let's see. We can start with summation of forces in the x direction. Summation of forces in the x direction. So just, again, kind of bear with me a little bit. So there's a ABX component. There's a BCX component, which is in the negative direction based on my assumption. And there's a BGX component, also negative based on the direction that I chose. ABX we know. ABX we know. ABX is 27.04 0.04 sine 56.31 degrees. BCX is negative BC cosine 3369. And BG X is negative BG cosine 5631 degrees. That's where those came from. We can do a little bit of arithmetic, and eventually we get, all right, so by a little bit of arithmetic, I mean if we do the multiplication, this comes out to be 22.4987 kilonewtons. Plus negative 0.8321 BC plus negative 0.5547 BG. 5547 BG equal to 0. Just kind of clean it up. I'm going to take the constant and move it to the right-hand side. Negative 0.8321 BC plus negative 0.5547 BG is equal to negative 22.4987 kilonewtons. One equation, two unknowns. That's not going to help us very much. Our other equilibrium equation is summation of forces in the y direction. There are four this time. So we've got AB in the y direction. We've got negative 10 kilonewtons in the y direction. We've got a negative BC in the y direction, and we have positive BG in the y direction. ABY we know. That's 27.04 cosine 56.31 degrees minus 10 kilonewtons minus BC sine 33.69 degrees plus BG sine 56.31 degrees. Almost ran out of paper there. So let me kind of show you where those are. AB, BCY, and BG. Doing the arithmetic. These two pieces here combine. There we go. These two pieces combine. When you do the arithmetic, they come out to be 4.999 kilonewtons minus BC sine 33.69 degrees, which we can actually calculate. Might be easier so we don't have to keep writing the sine piece over and over and over again. 0.5547 BC plus 0.8321 BG is equal to 0. Subtract 4.99 from both sides, leaving us with 0.5547 BC plus 0.8321 BG is equal to negative 4.999 kilonewtons. Oh boy. What do we have here? Looking at this equation and this equation, So we have two equations and two unknowns, so we'd have to solve that using systems of equations, which I did. And when you solve, if you do it right, you get that BG is equal to 8.3196 kilonewtons, and BC is equal to 21.49 kilonewtons. So I solved this by, solved by system of linear equations. Let me go fill that in while you guys look at that. 8.3196 kilonewtons. It came out to be positive, which would be an indication that BG is in compression. I guessed the arrow correctly. BC 21.49 degree or 20 kilonewtons. Also came out to be positive, meant that I guessed that one correctly as well. Go make some check marks about what we've got. So I just got BG and DF, BC and DC. So really kind of leaves us just 2 left to do. I'm gonna pause this while I erase the board. I'll be right back and we'll do the last part of the problem. Welcome back. I have, so we've, just to review, we only have 2 members left to well, we have 3, but we know that CG and CF are gonna be the same. So I'm gonna work from point G. I filled in AG, we already have. AG was calculated earlier. It's in tension, hence the arrow going away. BG compression, hence the arrow going into. Let's go ahead and grab, so BG is at a diagonal, so we know we're going to need a X and a Y direction for that, or X and Y component. So it's going down, which means that Y would be in the negative direction, X would be in the positive direction. 8.3196 kilonewtons is BG. This angle is 56.31 from a previous calculation. So the X component, 8.3196, cosine 56.31 degrees. And the Y component, 8.3196 kilonewtons times the sine of 56.31 degrees. CG, so I've got CG going in the upward direction. That's true. And the X would be going to the right, which is positive. The Y would be going up, which is positive. Here's CG, good old CG. And from a previous calculation, this is 67.34 degrees, which means that GC or CG in the X direction, cosine 67.34 degrees, and Y direction, CG sine 67.34 degrees. So hopefully we have everything that we need. We'll know soon enough, that's for sure. I'm gonna start in the Y direction, mainly because I have one known in the Y direction, that's BGY, and one unknown. So BGY, which is going to be negative, and CGY, which is positive. So BGY is negative 8.3196 sine 56.31 degrees plus CG sine 67.34 degrees equal to 0. Add, well, let me write out where we got it from. So CGY and CGY. That's this one and that one. There we go. All right, back to work. Solving for CG. In other words, add this to both sides, then divide by sine 67.34. We get that CG is equal to 7.5017 kilonewtons. Go ahead and fill that in real quick. 7.5017 kilonewtons. It came out positive, which indicates that I have the direction in the correct arrow. In this case, that indicates tension because The reaction at the pin is pulling away, which means the member is pushing into or pulling apart the member. And finally, in the X direction. So in the X direction, we have AG, BGX, CGX, GF. So AG, GF, BGX, and CGX, for those that like that. 22.5 kilonewton plus 8.3196 kilonewtons times the cosine of 56.31 degrees. You are correct. AG should be negative. Thank you. BGX is positive. I have CGX in the positive direction. And I have GF in the positive direction. And we actually know CG, so we can put that in. That was 7.5017. Seven 0.5017 kilonewtons. And that's equal to 0 because it's at equilibrium. Perform the indicated arithmetic. We get the GF is equal to 14.9954 kilonewtons. That's the last of our unknowns. And I have it, that came out positive, which indicates that I have the arrow in the correct direction. So GF is in tension. Hope this was helpful. Provide me some feedback in the comment section. See you in a little while.